otherwise be possible. In addition to its aesthetic appeal, SOS J1038 plus 4849 plays a critical role in advancing our understanding of dark matter. Since dark matter does not emit, absorb, or reflect light, its presence can only be inferred through gravitational effects. The distribution of dark matter within the cluster can be mapped by analyzing the precise distortions in the arcs and rings caused by gravitational lensing. By studying these distortions, scientists can construct mass models of the galaxy cluster, revealing not only the location of dark matter, but also its relative density and influence on surrounding structures. Further studies of this galactic grin have utilized multi-wavelength observations, combining optical, infrared, and X-ray data to paint a comprehensive picture of the cluster's composition and activity. X-ray emissions detected in the region indicate the presence of superheated gas trapped within the cluster's gravitational potential well. This gas, reaching millions of degrees in temperature, is a vital component of the cluster's total mass and contributes significantly to its gravitational lensing power. The luminous lens has also become a focal point in research exploring the formation and evolution of galaxies in the early universe. The magnification provided by gravitational lensing allows astronomers to observe galaxies that formed mere hundreds of millions of years after the Big Bang. These young galaxies are often too faint to be studied directly, but the lensing effect amplifies their light, enabling detailed spectroscopic analysis. Through these observations, scientists are piecing together the processes that govern star formation, galaxy mergers, and the growth of supermassive black holes in the universe's infancy. Moreover, the study of gravitational lenses like the cosmic arch aids in refining cosmological models. By analyzing the distortions in light caused by such lenses across vast cosmic distances, researchers can measure the Hubble constant, a critical parameter that quantifies the rate of expansion of the universe. Discrepancies in measurements of the Hubble constant obtained through different methods remain one of the most perplexing challenges in modern cosmology, and systems like SOS J1038 plus 4849 are crucial in addressing this tension. The discovery and continued exploration of this galactic smile exemplify the synergy between advanced observational technologies and theoretical physics. While its iconic appearance has captured the imagination of the public, its true value lies in the wealth of scientific data it provides. Each arc of light represents an untold story from the cosmos, a story of galaxies billions of light years away, of dark matter shaping the universe, and of the fundamental forces that govern existence. SOS J1038 plus 4849 is not merely a happy accident of the cosmos, it is a testament to the interconnectedness of all things, from the smallest particles to the grandest galactic structures. As telescopes grow more powerful and computational models more sophisticated, this celestial wonder will undoubtedly continue to yield new discoveries, deepening our understanding of the universe and our place within it. Beyond the current studies, the smiling galaxy cluster offers vast potential for future research, especially as next-generation observatories like the James Webb Space Telescope, JWST, and the Vera C. Rubin Observatory come online. These advanced facilities will allow astronomers to probe even deeper into the cluster's structure and the distant galaxies magnified by its gravitational lensing. The JWST, with its unparalleled infrared sensitivity, is particularly well suited for studying the faint, red-shifted light of the most distant galaxies amplified by this lensing effect. Observations through SOS J1038 plus 4849 are expected to reveal the chemical composition, star formation rates, and structural evolution of these primordial galaxies, helping to refine models of how the first galaxies formed and evolved. Additionally, the JWST can detect the presence of early supermassive black holes, shedding light on the mysterious processes that allowed such massive objects to form in the early universe. The Vera C. Rubin Observatory, on the other hand, will provide a complementary view through its wide-field imaging capabilities. By capturing transient events within the cluster, such as supernovae in lensed background galaxies, the observatory will allow astronomers to measure time delays between multiple images of the same event. This phenomenon, known as time delay cosmography, offers a unique method for measuring the Hubble constant with unprecedented precision. These measurements will be critical for addressing the ongoing Hubble tension, a major unresolved discrepancy in cosmology. Meanwhile, simulations of the cosmic grin using advanced computational models are becoming increasingly detailed. These simulations not only recreate the lensing effects observed in SOS J1038 plus 4849 but also incorporate theoretical predictions about its behavior and distribution. By comparing simulations to actual observations, scientists can test the validity of different dark matter theories, including whether dark matter consists of weakly interacting massive particles, WIMPs, axions, or other exotic particles. SOS J1038 plus 4849 also serves as a natural laboratory for understanding galaxy cluster dynamics. The galaxies within the cluster are not stationary, they move under the influence of the cluster's gravitational field and interact with one another. These interactions can trigger star formation, disrupt galactic structures, and even lead to the merging of galaxies. By studying these processes in detail, researchers can better understand the role of environment in shaping the evolution of galaxies. Another promising avenue of research involves the cluster's impact on the cosmic microwave background, CMB. As the relic radiation from the Big Bang passes through the galaxy cluster, it is subtly distorted in a phenomenon known as the Sunyaev-Zeldovich (SC) effect. This effect provides a powerful tool for measuring the cluster's total mass and temperature, as well as for probing the properties of dark energy, which drives the accelerated expansion of the universe. One of the most intriguing possibilities involves searching for evidence of modified gravity theories. Some alternative theories of gravity, which aim to explain cosmic acceleration without invoking dark energy, predict subtle deviations in gravitational lensing patterns. The high-precision data from systems like SOS J1038 plus 4849 could reveal these deviations, offering a direct test of such theories and potentially revolutionizing our understanding of gravity itself. The smiling face in the cosmos is also a poignant reminder of humanity's growing ability to unravel the universe's deepest mysteries. Its discovery and study represent decades of technological progress, theoretical innovation, and international collaboration. While its cheerful appearance has drawn widespread public attention, its true significance lies in the countless scientific opportunities it provides. In a way, SOS J1038 plus 4849 encapsulates the dual nature of astronomy. It is both a source of profound scientific inquiry and a source of wonder that connects us emotionally to the cosmos. As humanity continues to gaze deeper into the universe, clusters like this one will remain beacons of curiosity and discovery, guiding us toward new horizons of understanding. Yet, what truly sets the cosmic smile apart is its ability to pose more questions than answers, questions that challenge the limits of human understanding. What lies beyond the lensed galaxies that we can see? Are there even more ancient structures, obscured by the dense veil of space-time distortions, waiting to be uncovered by future advancements in observational technology? Each faint arc of light represents not only the history of a galaxy billions of light-years away, but also a portal into a time when the universe was still young and chaotic, shaped by forces we are only beginning to grasp. One of the most tantalizing mysteries hidden within SOS J1038 plus 4849 is the nature of dark matter itself. The gravitational lensing patterns we observe cannot be explained by the visible matter in the cluster alone. There must be an invisible mass component exerting an immense gravitational pull. Could this invisible architect of the universe be composed of particles we have yet to discover? Or, more intriguingly, could it point to an entirely new framework for understanding gravity and space-time? Moreover, the eerie precision of the smile itself sparks curiosity. Although the arcs and features can be scientifically explained by gravitational lensing, their almost anthropomorphic arrangement feels uncanny. It serves as a cosmic Rorschach test, igniting debates about our innate human tendency to find patterns, even in the chaos of the universe. This formation invites us to wonder, what other stunning visual phenomena might exist elsewhere in the vast expanse of space, waiting to be stumbled upon? Some researchers speculate that the regions magnified by this cluster might hold clues to one of the most elusive phenomena in modern physics, the cosmic web. The cosmic web is the intricate network of filaments and voids formed by dark matter and galaxies that spans the entire universe. Observing these lensed galaxies at different redshifts could help map this structure in unprecedented detail, potentially revealing how galaxies are funneled along these filaments to form clusters like the smiling galaxy. The cosmic grin also beckons the question of whether such phenomena could play a role in the search for extraterrestrial intelligence. If advanced civilizations existed in these distant galaxies, might they also be studying the lensing effect caused by their own galaxy clusters? Could gravitational lensing itself become a form of cosmic communication, amplifying signals across unimaginable distances? While speculative, these questions highlight the interconnectedness of every discovery in astronomy and its potential implications for understanding our place in the cosmos. Even more fascinating is the possibility that the light magnified through SOS J1038 plus 4849 contains signatures of the first stars, so-called population 3 stars. These stars, theorized to be the universe's first light sources, were composed entirely of hydrogen and helium, burning at incomprehensible temperatures and living short, explosive lives. Detecting the chemical imprints of these ancient stars would rewrite the story of the early universe, offering a direct glimpse into the very origin and matter. As we continue to study this smiling anomaly, one truth becomes increasingly clear: the more we learn, the more the universe reveals its boundless complexity. What began as a charming cosmic coincidence, a face staring back at us from the stars, has grown into a profound symbol of the mysteries that lie hidden in the fabric of spacetime. It's a reminder that every corner of the universe, no matter how distant or faint, holds the potential to reshape everything we think we know. In the coming decades, as humanity builds even more powerful telescopes, both on Earth and in space, the study of SOS J1038 plus 4849 will undoubtedly evolve. It is likely that this smiling cluster will not only continue to serve as a lens through which we peer into the universe's past but also become a touchstone for exploring fundamental questions about its future. Will the universe continue expanding forever? What role will dark matter and dark energy play in its ultimate fate? Could there be other faces in the cosmos, quietly waiting to be discovered? The smiling galaxy cluster is more than a scientific curiosity or an aesthetic wonder. It is a challenge, a puzzle, and an invitation. It dares us to explore, to question, and to dream. And as we stand at the threshold of new discoveries, it whispers to us the most thrilling promise of all, that the universe, in all its complexity, still has secrets to share. The smiling galaxy cluster is also a profound testament to the sheer scale and interconnected nature of the universe. The light we see from the lensed galaxies within this cluster has traveled billions of years to reach us, crossing unimaginable distances through a universe that has expanded and evolved since the moment these photons began their journey. In this sense, observing SOS J1038 plus 4849 is akin to looking through a time machine, offering us a snapshot of the cosmos as it existed eons ago. But this glimpse into the past isn't static, it's dynamic. The light curves, distortions, and relative positions of the lensed galaxies change with time, albeit on timescales that challenge human perception. This has sparked interest in monitoring gravitational lenses like the cosmic smirk over decades to detect subtle changes in the background galaxies or even reveal new ones as the universe continues its inexorable expansion. This ongoing evolution offers an extraordinary opportunity to test and refine our cosmological models. One of the most intriguing areas of research involves the interaction between dark matter and visible matter in the cluster. Scientists have noted that the smile features of the lensing pattern align closely with simulations of dark matter halos surrounding galaxy clusters. These halos are thought to be the scaffolding upon which galaxies form and evolve. By studying how these halos distort the light of background galaxies, researchers can directly probe the properties of dark matter, its distribution, density, and behavior under extreme gravitational conditions. Some hypotheses even suggest that dark matter might interact weakly with itself, and gravitational lenses like SOS-J 1038 plus 4849 might hold the observational evidence needed to confirm or refute these theories. The gravitational lensing phenomenon also opens a door to explore regions of the universe that remain forever hidden. Deep within the arcs and rings of light, astronomers are beginning to uncover faint galaxies that represent the building blocks of larger structures. These ancient galaxies are like fossils, providing evidence of the chaotic and violent processes that dominated the early universe. Their distorted images reveal how gravity sculpted the first galactic structures, merging smaller systems into the massive galaxy clusters we observe today. Interestingly, the smiling cluster is not alone in creating such mesmerizing effects. There are other gravitational lenses scattered across the universe, some forming equally breathtaking shapes, such as Einstein rings and cross-like patterns. What makes SOS-J 1038 plus 4849 unique, however, is the uncanny symmetry of its features, a near-perfect alignment that makes it one of the most iconic gravitational lenses ever discovered. This symmetry is incredibly rare and may provide clues about the cluster's specific geometry, mass distribution, and the line of sight alignment required to produce such a striking image. Another promising area of investigation is the role of gravitational lensing in magnifying transient cosmic events. Supernovae, gamma-ray bursts, and even kilonovae, cataclysmic explosions caused by neutron star mergers, can be magnified and distorted by galaxy clusters like SOS-J 1038 plus 4849. These magnified events provide a window into the most extreme environments in the universe, offering unparalleled detail about the physics of stellar deaths and the creation of heavy elements. For instance, The light from a supernova behind the cluster might appear multiple times, separated by months or even years, due to the different paths taken by light rays through the lens. By observing these repeated appearances, astronomers can measure cosmic distances with remarkable precision. Perhaps most exciting is the potential for gravitational lensing to aid in the detection of elusive phenomena like primordial black holes or exotic particles predicted by advanced theories of physics. If such objects exist, they could create subtle perturbations in the lensing patterns observed in clusters like SOS J1038 plus 4849. Detecting these anomalies would not only confirm the existence of these hypothetical entities but also open entirely new chapters in our understanding of the universe's fundamental building blocks. The galactic smile also serves as an inspiring symbol of the interdisciplinary nature of modern astronomy. Its study requires expertise in observational astrophysics, theoretical physics, computer modeling, and even artificial intelligence, which is increasingly being used to analyze the vast amounts of data generated by gravitational lensing studies. Machine learning algorithms can identify lensing patterns in telescope images far more efficiently than humans, accelerating the discovery of new lenses and enabling researchers to focus on interpreting the data. And yet, even as technology advances, the smiling cluster remains a deeply human story. It reminds us of the wonder and curiosity that drive exploration, the power of science to uncover hidden truths, and the profound interconnectedness of the universe. It challenges us to look beyond the surface, to see patterns where others might see chaos, and to find beauty and meaning in the most unexpected places. In many ways, the study of SOS J1038 plus 4849 is only beginning. As telescopes become more powerful and our theoretical models more refined, this smiling face in the cosmos will continue to inspire, challenge, and enlighten us. What other secrets does it hold? What new questions will it raise? Only time will tell. For now, the smiling galaxy cluster stands as both a puzzle and a promise, a beacon in the vast, uncharted sea of the universe, inviting us to explore further, dig deeper, and dream bigger than ever before. The intrigue surrounding the smiling galaxy cluster deepens as we consider the uncharted possibilities hidden within its arcs of light. What if the gravitational lensing we observe in SOS J1038 plus 4849 is just the beginning, a doorway to phenomena yet unknown? The universe has a way of surprising us, and this cluster may hold secrets far beyond what current scientific understanding can predict. For instance, scientists are beginning to explore the idea that gravitational lenses like the cosmic smile could reveal traces of exotic matter beyond dark matter, perhaps remnants of primordial black holes or even hypothetical particles like sterile neutrinos. These exotic entities, if present, could leave subtle fingerprints on the lensing effects, warping the arcs in ways that defy standard predictions. Could SOS J1038 plus 4849 be hiding such anomalies in plain sight, waiting for technology to catch up with its mysteries? Even more tantalizing is the idea that the light from this cluster might carry clues about the fabric of spacetime. Some theories propose that the structure of spacetime itself is not smooth, but rather has a quantum graininess at the smallest scales. This graininess, if real, could subtly distort the paths of photons traveling across vast cosmic distances. If detected in the lensing patterns of SOS J1038 plus 4849, it would revolutionize our understanding of the universe, potentially merging quantum mechanics and general relativity into a unified framework. But the mysteries do not end there. The background galaxies magnified by the cluster's gravitational field offer a window into some of the most extreme environments in the cosmos. Among these, astronomers suspect there may be evidence of early quasars, massive black holes devouring matter at the centers of young galaxies. These quasars, visible only thanks to the cluster's lensing power, could provide critical insights into the formation of supermassive black holes. Were these cosmic giants born massive, or did they grow over billions of years by consuming gas and merging with other black holes? The light amplified by the smiling cluster might hold the answers. And what of the strange symmetry of the cluster itself? While gravitational lensing is well understood in terms of physics, the precise arrangement of features in SOS J1038 plus 4849, a nearly perfect smile and eyes, remains a statistical anomaly. Could this symmetry point to an underlying order in the cosmos, something beyond random chance? Some theorists have even speculated that such alignments could be evidence of large-scale cosmic structures or patterns, echoes of the primordial conditions that shaped the universe in its earliest moments. Even more speculative are the philosophical implications of such discoveries. If the smiling cluster reveals a deeper cosmic order, what does that say about our place in the universe? Are we merely observers of an intricate, random ballet of matter and energy, or is there a deeper connection between the patterns we see and the nature of existence itself? This cosmic smile, while scientifically explainable, feels almost as if the universe itself is acknowledging our curiosity, encouraging us to continue asking questions. The study of SOS J1038 plus 4849 also challenges us to think on timescales far beyond human comprehension. The light from these distant galaxies began its journey when Earth was still forming, billions of years before life as we know it existed. This light has traveled uninterrupted through the vast expanse of an ever-expanding cosmos, only to reach our telescopes now, in this fleeting moment of human history. It's a humbling reminder of how small and transient we are in the grand scheme of things, and yet, it also highlights the power of human ingenuity to decipher the cosmos. And what of the future? As telescopes grow more advanced, what else might they uncover in this cluster and others like it? Could there be even more complex lensing effects, perhaps revealing entire galaxies hidden behind the glare of brighter objects? Could there be gravitational echoes of unseen objects, rogue planets, wandering stars, or even isolated black holes, imprinted on the light that reaches us. The smiling galaxy cluster serves as a cosmic treasure map, pointing us toward discoveries that may fundamentally alter our understanding of the universe. In the end, SOS J1038 plus 4849 is far more than just a beautiful image or a scientific curiosity. It is a challenge, a mystery, and an invitation to explore the limits of human knowledge. As we stare into the cosmic smile, we are reminded of the infinite possibilities that lie beyond, waiting for us to uncover them. And perhaps, just perhaps, the greatest discoveries of all are those we have yet to even imagine. The mysteries of the smiling galaxy cluster deepen when one considers the potential for this gravitational lens to reveal truths not only about the distant past, but also about the fate of the universe itself. The light that has been bent and distorted into arcs and rings offers clues not only about the galaxies behind it but also about the invisible forces shaping the cosmos. Could SOS J1038 plus 4849 hold the key to understanding the ultimate destiny of the universe? One of the most profound questions in modern cosmology concerns the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. The smiling cluster provides a unique laboratory for studying this enigmatic phenomenon. By analyzing how the cluster distorts light from distant galaxies at varying redshifts, scientists can measure the universe's expansion rate over time. These measurements could help refine the elusive Hubble constant, the value that quantifies this expansion. But what if the results defy current theories? What if SOS J1038 plus 4849 reveals evidence that the expansion of the universe is not constant but fluctuates in ways we cannot yet explain? Even more intriguingly, some researchers speculate that gravitational lenses like this one could uncover evidence of phantom energy, a hypothetical form of dark energy that grows stronger over time, potentially leading to a big rip. In this scenario, the accelerating expansion of the universe would eventually tear apart galaxies, stars, and even atoms themselves. Could the light passing through the smiling galaxy cluster be whispering hints about this apocalyptic future? Beyond dark energy, the cluster's gravitational lensing also provides a window into the earliest epochs of cosmic history. The light from the magnified galaxies behind SOS J1038 plus 4849 may carry the faint signatures of the reionization era, a period when the first stars and galaxies began to ionize the hydrogen that filled the universe after the Big Bang. Studying this light in detail could reveal when and how this critical transition occurred, offering a glimpse into the dawn of structure formation in the cosmos. But what if it also reveals something unexpected, anomalous patterns in the distribution of matter or light that challenge our current understanding of the early universe? One of the most tantalizing possibilities is that the smiling cluster could help confirm, or refute, the existence of hypothetical particles like axions. These particles, if they exist, might constitute a significant portion of dark matter and could subtly alter the way light behaves as it passes through the gravitational field of the cluster. Detecting such effects would not only solve one of the greatest mysteries in physics but also open a new chapter in our understanding of the fundamental forces shaping reality. The symmetry of the smile itself also raises fascinating questions about the nature of chance and alignment in the universe. Why do we see such a perfect arrangement of features in this cluster? Is it a coincidence, or could it point to a deeper underlying structure in the cosmos? Some theorists suggest that such alignments might be more common in a universe governed by principles we do not yet fully understand, principles that could hint at higher dimensions, or even multiverse theories. Could the smiling galaxy cluster be a subtle clue pointing toward a broader, hidden framework of reality? As humanity prepares for the next generation of astronomical tools, including projects like the European Extremely Large TEL-T and advanced space-based observatories, the potential for discovery surrounding SOS J1038 plus 4849 only grows. These instruments will allow us to study the cluster in unprecedented detail, detecting faint distortions and faint galaxies that current telescopes cannot resolve. They might even reveal gravitational lensing effects caused by smaller scale structures, such as rogue black holes or dense clumps of dark matter. In the distant future, as humans venture beyond Earth to establish observatories on the Moon or Mars, the smiling cluster could become a cornerstone for interplanetary science. Observations from different vantage points in the solar system could provide new insights into how light bends around massive objects, offering a unique test of Einstein's theory of general relativity on cosmic scales. But perhaps the most profound mystery of all lies in the cluster's ability to inspire. Why does the sight of a smile in the cosmos resonate so deeply with us? Is it because it reminds us of our own humanity, our quest for meaning in the vastness of space? Or is it because, on some level, it feels like the universe itself is acknowledging our curiosity, inviting us to look closer, dig deeper, and dream bigger? The smiling galaxy cluster is more than just a gravitational lens, it is a message. A message that the universe, vast and mysterious as it is, still has wonders to reveal. And as we continue to peer into its smiling face, we are reminded that every discovery brings us closer to understanding not just the cosmos, but our own place within it. As we continue to explore the mysteries of the smiling galaxy cluster, one cannot help but imagine the countless untold stories hidden within its arcs of light. Every curve, every distortion, is a silent testament to the cosmic forces at play over billions of years. Yet, while we marvel at the patterns we can see, we must also consider the invisible, the unseen players shaping this galactic masterpiece. Among these invisible forces, dark matter looms largest. We know it is there, not from direct observation, but from its undeniable effects on gravitational lensing. In SOS J1038 plus 4849, the precise arcs and shapes of the lensed galaxies reveal the distribution of this mysterious substance. But what if the cluster holds clues about something even stranger? Some theories propose that dark matter could be self-interacting, meaning that it might collide and interact with itself under specific conditions. This behavior, if detected, would upend our current understanding of the cosmos, forcing us to rethink the role of dark matter in shaping galaxies, clusters, and the universe as a whole. Beyond dark matter, there is the tantalizing possibility of uncovering evidence of even more exotic physics. Could there be new particles or forces influencing the light that bends through this cluster? Some researchers have speculated that phenomena like sterile neutrinos or ultralight axions could leave subtle, detectable imprints in gravitational lensing patterns. These discoveries would not only solve long-standing mysteries about the nature of the universe but could also point to entirely new realms of physics, pushing the boundaries of what we thought possible. Yet the mysteries of the smiling galaxy cluster do not end with the physical. There is also the philosophical, the strange symmetry of its features, the almost deliberate way it seems to form a face. Some have argued that this is merely a trick of perspective, a random alignment of cosmic elements. But others wonder, what if there is something deeper at play? What if the universe is governed by hidden patterns, an order we are only beginning to glimpse? The cosmic smile is a reminder that the universe is not just a collection of random events, it is a tapestry of connections, each thread weaving into another to create the grand design we call reality. The gravitational lensing of SOS J1038 plus 4849 also invites us to consider the sheer scale of the universe. The galaxies behind the cluster, magnified into arcs and rings, are not just distant, they are ancient. They formed when the universe was a fraction of its current age, during a time when the first stars and galaxies were struggling to emerge from the primordial darkness. Their light has traveled billions of years to reach us, carrying with it a story of creation, destruction, and evolution. In studying these galaxies, we are not just looking at objects, we are looking at epochs, snapshots of a universe in flux. What's even more fascinating is that this light, distorted and magnified by the cluster, allows us to see deeper into the universe than ever before. Gravitational lensing acts as a natural telescope, amplifying faint and distant objects that would otherwise remain invisible. But what if the smiling cluster reveals something entirely unexpected, perhaps galaxies that formed earlier than current theories allow, or even hints of phenomena that predate the Big Bang itself? Such discoveries would force us to reconsider the very foundations of cosmology, reshaping our understanding of the universe's origins and ultimate fate. There is also the question of what lies hidden within the cluster itself. SOS J1038 plus 4849 is not just a lens. It is a bustling community of galaxies, each with its own history and mysteries. Within this cosmic neighborhood, stars are being born and dying, supernovae are exploding, and black holes are consuming matter. Could the cluster harbor phenomena we have never observed before, such as intermediate mass black holes or rogue stars ejected from their galaxies? Could it even contain objects that defy classification, existing outside our current understanding of astrophysics? The more we study this cluster, the more to offer: a gateway to the past, a laboratory for testing the limits of physics, and a mirror reflecting our deepest questions about existence. As we build more powerful telescopes and develop more sophisticated models, the smiling galaxy cluster will undoubtedly reveal even more of its secrets. But it will also remind us of how much we have yet to learn, how much remains just out of reach. And so, we are left to wonder, what will we discover next? Will the light from this cluster reveal a new force of nature, a hidden dimension, or the first whispers of a parallel universe? Or will it simply deepen the mystery, showing us how little we truly know about the cosmos? The smiling cluster is a challenge, a cosmic puzzle that dares us to push the boundaries of science, to question everything we think we know, and to embrace the unknown. As we peer into the face of the universe, shaped by light and gravity, we are reminded of one undeniable truth: the universe is alive with wonder, waiting for us to explore its depths. And in that exploration, we may one day find answers not only to the mysteries of the cosmos, but to the mysteries of ourselves. For in the smile of a galaxy cluster, we see not just the universe, but the boundless curiosity of humanity staring back. The smiling galaxy cluster, SOS J1038 plus 4849, is more than a snapshot of the distant cosmos. It's an evolving story, one that intertwines humanity's pursuit of knowledge with the mysteries of the universe. Every detail of this gravitational lens hints at layers of complexity that we have only begun to unravel. But what if the most extraordinary discoveries are the ones we have not yet considered? One of the most exciting prospects is the potential for SOS J1038 plus 4849 to challenge the standard cosmological model. Our current understanding of the universe, known as lambda cold dark matter, lambda CDM, rests on the interplay of dark energy, dark matter, and ordinary matter. While this model has successfully explained many phenomena, gravitational lenses like the cosmic smile offer a unique opportunity to test its limits. If the mass distribution inferred from the lensing effects deviates from predictions, it could signal the need for a new paradigm, one that might incorporate unknown physics or revise our understanding of the universe's structure. The cluster's role as a lens also invites speculation about what lies behind it, even farther than the magnified galaxies we can currently observe. Could it reveal the light from the universe's first moments, perhaps the elusive population 3 stars, the very first stars ever to form? These stars, composed purely of hydrogen and helium, have never been observed directly. gravitational lenses like SOS J1038 plus 4849 could amplify their faint light, providing a glimpse into the cosmic dawn. Such a discovery would be revolutionary, offering direct evidence of the universe's transition from darkness to light. But the cluster's lensing potential extends beyond stars and galaxies. Some scientists believe that gravitational lenses might one day help detect other phenomena, such as cosmic strings, hypothetical defects in spacetime left over from the universe's formation. If these strings exist, they could subtly warp spacetime, creating unique and distinctive lensing effects. Could the smiling cluster be harboring such hidden relics of the early universe, waiting to be detected by the next generation of telescopes? The cluster itself also presents mysteries. Its mass is distributed in a way that creates an almost uncanny symmetry in the lensing effects, forming the distinctive smile and eyes. But why so precisely? Such a perfect is incredible.